morning, everyone. Today's lesson will focus on geometry and measurement. Cross-sections of three-dimensional figures is the title for those of you taking notes. Our learning objective today is learners will be able to describe the two-dimensional figures that result from slicing three-dimensional figures. Before we begin, let's go over the key vocabulary terms that you had to define last night. Cross-section is a cutting or piece of something cut off a three-dimensional shape. Vertical, upright or up and down. Horizontal, going across left to right. Prism, a polyhedron with two parallel congruent faces called bases. Pyramid, a polyhedron with one base that is a polygon and three or more triangular faces that meet at a common vertex. Time to engage. Students, if I can call your attention over to the smartboard. Okay. We will begin by completing the iReady lesson, Understanding Plane Sections of Pyramids and Prisms. Let's begin.
What's better than sliced bread? Of course, German bread slices.
Now that we all have an understanding of cross-sections, there are materials at each table. In order to construct three-dimensional figures with Play-Doh, perform a given cross-section and determine the two-dimensional shape that results from the slicing of the three-dimensional shape. You're going to record your answers on the provided worksheets. I will demonstrate two cross-sections. The first is of a rectangular prism with a horizontal cross-section. Let's see what happens. You are going to go ahead and mold your Play-Doh into the rectangular prism, as so. After you have molded, you should end up with your rectangular prism, just like so. Taking your student ID badge, you are going to go ahead and perform that first horizontal cross-section on a flat surface. So horizontal goes across, like so. The purpose is to go ahead and identify the shape that is made from this cross-section. So when you go ahead and take the two pieces apart, the shape that is made is a rectangle, correct? The next shape that we are going to go ahead and mold is a square pyramid, like so. Instead of making a horizontal cross-section like so, we are going to make a vertical cross-section like this. So if we can put it down on a flat surface and then make our cross-section with both our pieces like so, what shape was made when the shapes are pulled apart? A triangle. Correct. Now it's your turn to engage. Discussion time. Are the two-dimensional shapes created by slicing three-dimensional shapes dependent on the position of the cut performed, vertical or horizontal? Please post your answers on the discussion board in Edmodo. Looking forward to your responses. Students, if you have completed your cross-sections, your follow-up activities are to complete the iReady quiz from the cross-section lessons we started as a whole group activity and practice identifying cross-sections on Math IXL. Lesson Z4, due next class. References have been provided for sources used throughout the presentation. Thank you to my professors and colleagues for all the feedback and support during this course.